welcome to an introduction into Planet products within the defence and intelligence sector. I'm your presenter, Rhodri Phillips, and I'm a pre-sales engineer at Planet. So the two fleets that we operate here at Planet are the PlanetScope Doves and our SkySat constellation. The Doves are a very large fleet of a 4-band imaging satellite that are mapping the world almost every single day at a 3.7 meter resolution. There's no tasking involved here. They're just constantly capturing the Earth on a near daily basis. Our SkySats are the VHR, or very high resolution 50 centimeter product, imaging in RGB and near infrared, as well as the panchromatic band. SkySats are a tasking satellite and offer SubDaily Captures globally. This is what our Doves look like, just for reference. This is about the same size as a loaf of bread. So we've been constantly updating our Doves since the first launch in 2014. We have 3 generations of the Dove satellite: the Dove Classic, the Dove R, and the Super Dove. The main differentiators are the spectral bands and footprint size. We can see that the Super Dove is by far the larger of the 3 and provides additional bands. We're actually aiming to roll out the 8-band Super Dove product later this year. The additional bands, as we can see in this graphic, are the coastal blue, an additional green, a yellow, and the red edge band. The graphic demonstrates the wavelength versus spectral response of each band, and we can see the Super Dove bands seem rather well aligned to Sentinel-2, which means the use of the 2 datasets in collaboration will be reasonably simple. So now I'll dive a little deeper into our high-resolution SkySat constellation and give an indication of its capabilities. This slide just gives us a snippet into what the SkySat looks like, as well as the high-resolution imagery that it produces. So this slide here just gives an overview of the camera attributes. Our SkySats have 3 cameras per sat, which capture overlapping strips in scenes. And this is demonstrated in the graphic to the right-hand side of the slide. We then process the scenes, stitch them together, and orthorectify to produce a collect. The 2 collection types we have are the point and strip collect. The point collect is a 5.5 by 5 kilometer, 25 square kilometer collection, and the strip collect has the same width, however, with a 200 kilometer length. So the video demonstrates the orbit for the SkySats and Doves. This is known as a Sun Synchronous Orbit, which enables us to capture any point on Earth at the same time locally. This is approximately 10:30 a.m. and 1 p.m. What we've done with our new block of satellites, of the Block 3 SkySats, is put them into an inclined plane of about 53 degrees tentatively. Doing this has allowed us to increase our capture rate, meaning more revisits per day, depending on the latitude of your target. But let's say those revisits will be distributed over a 3-hour time frame. The time frame will shift throughout the year. If we capture an image at about 1 p.m., the capture time the following day will be about 1:02 p.m. So this provides vantage points never previously seen by commercial imagers. This is the end-to-end workflow for a customer requesting collecting the data, and then delivery. We call that workflow the responsiveness of the system. So let's start with the left-hand side and go towards the right. It starts with the tasking API or tasking dashboard, where a customer will no longer have to email us. The goal is to actually get us out of the picture, us operators anyway. You can submit an order, it runs through our scheduling system and links it up to the satellite. The imagery is captured on the satellite, we then downlink it, and then we transfer it. So the first component of that is called reaction. The task and the API enables us to shrink that time frame, so you can actually submit an order and have us capture it in a matter of hours. We're constantly working on bringing that time frame down. Other improvements we will talk about later this year are in latency. So once we capture the data, it goes through a few steps, be it downlink, ground processing, authentication, etc., before we make it available to the customer through delivery, through our API and platform. As mentioned, processing has a few different levels. of image readiness, which we'll talk about in the following slides. With the imagery being captured after that 50 frames per second, and then having us process it into different products, packaging that, and then we'll deliver it at different stages to kind of shrink that latency as much as possible. So the mentioned mid-process products will be touched on in this slide. One of the means we have of shrinking that latency is delivering various components of the pipelines at different stages. We can see to the left, and I keep mentioning this high frame rate, the 50 frames per second. The left represents how we capture the data. So that's us scanning down, we're capturing those frames, and then to the right you can see how we package it. So we offer an all-frame product, which is essentially just delivering all those frames in a near raw format to the customer, so that they have the closest data to the sensor that we can offer. Below that, we have a fast-track product, which is actually strategically picking frames from within that product and getting them to the customer, as soon as they're ready. This is pre-processed, pre-auth rectified data, allowing us then to be able to capture, allowing us to be able to be capable of getting it out the door in a matter of 2 to 3 hours. This means 2 to 3 hours after capture, you'll receive it through our platform. And then finally, at the bottom, we have our basic L1Bs. This is also representative of our ortho products, where after the fast track product development, we introduced auth rectification, super resolution, pan sharpening, etc. Other aspects to make the imagery look great and to rectify it to the ground. And we offer that as a few different products, be it basic or ortho products or visual. And those are made available to the customer about 8 to 10 hours after capture. So I could break it down into use cases. I'd also like to touch on the main use of the all-frame capability. Currently, the most common use of the all-frame product tends to be for stereo imagery, where the customer wants to see the near raw format, which does not rely on the super resolution or auth rectification. What we get is how we capture the data, the telemetry of the spacecraft, and then they reconstruct all those frames into their own 3D models. Usually the customers that want this kind of format tend to have quite an advanced pipeline that rely on very core satellite-based data, and that's best provided as the all-frame product, or the L1A. The L1Bs are used more frequently for general Earth observation, for example, monitoring urban areas, maritime, commodities, defense purposes, etc. And these are very simple to use. You can just drag the scenes into a GIS viewer, whether it's ArcGIS or QGIS, and it's made available in whatever sort of color combination or band combination you'd like to see it. So from start to finish, in the best case scenario, where a target happens to be upcoming in front of a good ground station, you can place a task and receive data in less than 12 hours. It does depend on a few factors, which means the average would be closer to about 24, but in a best case scenario, 12 hours is certainly possible. And it's also important to understand the cadence these images can be captured at. Our revisit rate is second to none, meaning we're able to keep capturing imagery of targeted areas at high resolution on a sub-daily basis. So I've been talking about the on-demand tasking, which is a little like the previous examples of where we just point and kind of shoot at one particular AOI. What do we mean by monitoring, and what are base maps? So with our coverage from the SkySats, our monitoring capabilities is one of the best out there. We can image base maps, as you can see, the base map of Singapore to the right, and this was captured totally using SkySat. We have the tasking, which is a single point you can hit in a day based off customer request, so the flexible or assured tasking. We can have a standing target which will hit a repeat recurrence if a customer is interested in monitoring. For example, capturing a port every day, or every Monday, for a week or for a monthly cadence. Also with that coverage, rather than just imaging points as we do for on-demand monitoring and tasking, to the left, we also do offer large area mapping, and the base maps to the right. Having so many satellites overhead per day does allow us to capture these larger area strips, as I mentioned earlier, over and over, so we can actually map quite large areas quite quickly. This base map, the one to the right of Singapore, I believe was captured over a couple of weeks. And with the additional 6 satellites that were captured mid last year, this will actually decrease our capture time even more. And this is just the whole Singapore base map, as previously mentioned. I'd just like to add the difficulty of being able to capture not just a cloud-free base map, but a singular image, cloud-free of Singapore, being quite renowned for its cloud cover in the remote sensing world. To be able to create this over a couple of weeks is really quite impressive. Okay, so let's look at how planet data has actually been used within the defense and intelligence sector. So firstly, I'd like to start with these SkySat images pre and post explosion event that occurred in Beirut last year. The image itself was actually captured the morning after the explosion occurred. This allowed the user to immediately see the extent of the damage, which in turn helped recovery procedures. For another recovery and response use case, this GIF demonstrates our daily monitoring capability mentioned in the previous slides. As we can see, this oil processing facility in Saudi Arabia had been captured every single day from the 15th to the 23rd of September in 2019. The images themselves monitor the response after a missile attack on one of their oil processing centers. Additionally to just imagery, we also offer a range of analytic feeds. So using our daily PlanetScope imagery, we produce a ship detection feed to give an idea of the movements of vessels within ports. In this example, in Bandar Abbas, Iran, this port is quite active and the ships change locations all the time, which can lead to interesting and very specific patterns of life for defense and intelligence customers. The imagery is used to detect vessels and create a GeoJSON file to easily visualize them and then easily compare. And this is just, I'll flick between these slides, but this is just an indication of what the results look like. Additionally to ship detection, we also have analytics for airplane detection, road building analytics, as well as well pad detection. But as we operate 2 constellations, it makes sense to collaborate them. By using daily PlanetScope to get an idea of pattern of life or situational awareness, the tip and queue system kind of works quite well. The tip being the daily imagery from PlanetScope allows us then to queue up a SkySat and get that 50 centimeter resolution for the more intricate details. So for this example, we're looking at Keshem Island port, just off the coast of Iran. Keshem Island is an Iranian island on the Hormuz Strait. The Hormuz Strait is quite a popular shipping route for all manner of things, but it is also defined as a choke point in military terms. In the next few slides, I will demonstrate how both of our constellations have been used to identify an expansion of an airfield, the construction of road infrastructure, and the construction of a port, more or less in the same time period. As PlanetScope is constantly capturing, we're able to look at the changes in the medium resolution detail at a near daily frequency. And this information can give an indication of perhaps unusual activity that may need to be looked at in a little more detail. Using the tip from the PlanetScope imagery and the tasking dashboard or API, we can queue up a SkySat image almost immediately to see what's going on at that higher detail. So flicking between these 2 images, without showing you all the images in between, because there are a lot, we can see that there's been substantial construction on the port and then also the road just to the north. And I've shown this in the red box, but this information was justification enough to then queue up a SkySat. So I'll go through a few of the images throughout the year, just to give you an indication of the time frame of construction. This is 11th of October 2018, 29th November, 9th of December. You can see the steady construction of the port. 3rd of January, 19th of September, you can see a significant increase in construction. And then finally the 26th of December in 2019. And on the 27th of December 2019, we're able to queue up that SkySat. So within 24 hours of the PlanetScope tip, we have a cloud-free SkySat image giving us information about the vehicles, about the buildings, and just having an in-depth look at what's on the ground. So the same goes for the extension of the runway. This first image is 21st of December 2017, so a little bit before the port images. And this includes image prior to any construction of the runway. 22nd of March, you can see it's starting to expand. 29th of April, 15th of June, and 26th of December. The daily imagery can identify changes over time, tracking the trends and monitoring the movements, ultimately providing the user then with situational awareness. So my second example is of the US air-based drone attacks in Iraq, January 2020. Again, daily PlanetScope imagery and the ability to look into the archive, which, as I said, dates back to 2014, gives us an idea of what was going on the ground, and then the SkySat is tasked for a higher resolution look. This was the most recent SkySat prior to the drone attacks for reference, on the 25th, I believe, December 2019. And the attack sites we will see in the forthcoming imagery are identified using the white boxes. So I'll showcase some PlanetScope imagery leading up to the attack. We can see the movement of larger vehicles, etc. throughout the imagery. So we'll start with this image from the 3rd of January. The 4th of January, you can see the movement of vehicles, within a day. 5th of January, 7th of January, and on the 8th of January, you might notice something. We actually have the first commercial image following the attacks from earlier that morning. And actually, due to having non-image information, we were actually able to task an image pretty much immediately, and therefore also have a SkySat from the exact same day. And finally, an image from the 10th to kind of give us an understanding of the response following the attack. But obviously, this is the detail that we get from SkySat. Obviously, not a very pleasant image to look at, but the information and the detail is there, which is unbelievably important. And these slides just give us a quick comparison of the PlanetScope imagery between the 3rd and the 8th of Jan. An indication of objects we can see from this kind of resolution at 3.7 meters. So finally, I'd like to showcase our SubDaily captures. This is actually an example we were capable of capturing with our fleet in 2019, so prior to our Block 3 SkySat. So we were six satellites less than we are now, and this is over the Abu Dhabi port in the UAE. We were capable of doing this in September 2019 because we had 2 satellites overhead in the morning and 2 in the afternoon. They're both pointing off Nadir to enable this kind of high revisit capability. However, with those additional 6 sats that we have now, it's going to become more of a novel operation that we're guaranteed pretty much every day. But you can see here 4 different satellites capture 4 images over about a 3-hour period. And it really just goes to show how we can monitor a pattern of life over a single point in any given single day. So if we look at each image individually, you'll notice that on the left-hand side, you can see the red and the kind of burgundy-looking ship. The brighter red ship is likely to be filling up its coal stockpile, and we'll see in the forthcoming imagery that it's getting ready to leave Abu Dhabi port. We'll also be seeing the movement of vehicles, whether they're in car parking lots or on the roads throughout the course of the day. So the first image is at about 7 minutes to 7 UTC, or 7 minutes to 11 local time. At 7:30 or 7:32 UTC, you can see that the red ship is starting to move, and obviously we can see the movement of certain parking lots fluctuating in the number of cars or vehicles. 2 hours later, we can see that the red ship is actually gone, and obviously we're still seeing the movement of vehicles in both the parking lot and actually the smaller port to the southernmost part of the image. And finally, we have an image only a couple of minutes later, but the information is still there. The focus of this is just to demonstrate that having 4 collections a day beyond the standard Sun synchronous orbit times have not really been available to the broader market ever. So this is just the first time that additional times throughout the course of the day are going to be available to users and customers, thus allowing the user to make much faster and informed decisions when it comes to whatever it is that they need to do. We'll know whether it's on the emergency management side of things, natural disasters, energy markets that are depending on activity, and refineries or coal stockpiles, etc. So thank you very much for your time today. I hope it's been interesting, and I'd be happy to answer any questions that you may have. Feel free to check out our website, or feel free to drop me an email via my Planet email address or via LinkedIn. Thank you.